Hello everybody, welcome to chapter 6. We're going to go ahead and solve systems of equations. We're going to be looking for either one solution, no solution, or all solution, and you can see the visuals of what each of those looks like. I'm going to go ahead and jump right into example number 1. We're going to use all three methods here. I'm going to start by showing you substitution. With substitution, you want to get either x or y alone in one of your equations. So in this first equation, I'm going to go ahead and get x alone by adding y to the other side. Now I'm going to go ahead and put that in for x into the second equation. So 2 times y plus 5, because that's what x is, plus y equals 1. Distribute, we get 2y plus 10 plus y equals 1. Combine like terms. Subtract that 10. Y is -3. So we found one part of that. The original equations have an x and a y, so we do need to find both. So I'm going to go ahead and put that into this equation that we solve for x. So we know that x is going to equal -3 plus 5, or x is 2. Always nice to write this as an ordered pair, having your x comma your y value. So that is solving with substitution. We'll go ahead and do elimination next. With elimination, we want to add or subtract our two equations and have one of the variables go away. If I add these two together, this is going to give me 3x, -y plus y is 0, equals 6, x is 2. Now again, I have to find x and y, so plug that back into either. I'm going to go into the first one, 2 minus y equals 5, -y equals 3, y is -3. Again, nice to write those as an ordered pair, so that way we know the x and the y. And then lastly, we have graphing. When we graph, we need to have a nice xy axis. Really better to graph this accurately, or else we won't see the solution very clearly, but I'll just give you an idea here. We need to get these both y equals before we graph. So on this first one, if I add y to the other side and subtract 5, we're going to get y equals positive x minus 5. The second equation, if I subtract 2x, y equals -2x plus 1. Graphing the first one, we have a y-intercept of -5. Big fat dot, slope is up 1 over 1. So we know that we have this line right here for that first one. The second line is a y-intercept of 1, down 2 over 1. We've got that one there. This point where they cross, that is our solution. It's a little bit tough to see here, but that should be at +2, -3, since we found it algebraically. Again, graphing, unless you're graphing super accurately, not a method I would pick. But hopefully that was a good reminder of all of those. Okay, so next, on example number 2, first of all, please change this to 4x plus 3y, or else we're going to have some really awful solutions. So please change that in your notes, first of all. I want to go ahead and give you a little bit of vocab here. When we're talking about dependent and independent. So dependent is when we get something where it's an all solution. Independent is everything else. That would be a no solution, or if we get just an answer. So my math lab's going to ask you this a lot. Are they dependent, independent, and are they consistent or inconsistent? You just need to remember that dependent means you're going to have an all solution, so the line is on top of itself, or it's independent, meaning everything else. For consistent, it means that we have at least one solution. And for inconsistent, we have no solution. So really, it's a no solution or everything else, if you want to think about it that way as well. So then, when you go to solve these, you still have to either do elimination or substitution. On this one, I would go ahead and do elimination. So I'm going to multiply this top guy by a -2, bottom guy by a +3. When I multiply the top by a -2, I get -8x minus 6y equals -22. On bottom, I get a -15x plus 6y equals 45. Now when I add these two equations together, this is going to give me a -23x, -6y, +6y are 5. And then negative 22 plus 45 is going to give me a 23. X would equal negative 1. So I know I can start my ordered pair over here, and it's going to be negative 1 comma something. Plug that back into either original. Let's go ahead and just go into the first one. So I get 4 times negative 1 plus 3y equals 11. Negative 4 plus 3y is 11. Add 4. 3y is 15. So y is 5. Okay, so we know that this is a solution. We're going to find the ordered pair at negative 1, 5, where these two lines cross each other. So we would state that this is independent because it's not an all solution. And then when we look at our consistent versus inconsistent, this is going to be consistent because there's at least one solution. So just get comfy with that vocab. So on top of solving, we just have to actually add in also these independent, dependent, consistent, inconsistent. All right, I'm going to go ahead and do these next two examples with you. Looking at this first one, again, on this, I would go ahead and do an elimination. So if we're going to do elimination, I would multiply this whole thing by positive 2, leaving me with positive 2x minus 6y equals 2. Add these straight down. The x's are gone, the y's are gone, so I have nothing on this side, and that equals 7. Well, 0 does not equal 7, so this is a no solution, meaning my lines are parallel. So these lines are parallel, they're never going to cross each other. So you need to look back on that other page where I was talking about what independent, dependent, consistent, inconsistent. This one is going to be independent because it's a no solution. And then for no solutions, those are inconsistent. So if you just look at those, again, like I said, you're solving, but you also need to know that vocab. All right, last example I'm going to do with you guys is this one. Again, I would go for an elimination on this. So I would multiply everything up here by a negative 2. Negative 4x minus 6y equals negative 12. When you add everything, you need 0 equals 0. Well, that's an all solution. So this means that they are the same line. They are on top of each other. So looking at that vocab again, for all solutions, this is going to be a dependent. And then at least one solution is consistent. So that's what we would write for those. The last 3 word problems I'm going to save for class, so please come with any questions that you have. And we'll finish this next time I see you.